Good morning, grade 8. We are now in the continuation of our topic. And by the way, before I forgot, I would like to congratulate everyone for the job well done last Science Month. Okay, you did a great job. Congratulations, everyone. And hopefully, you can nurture what you had learned with those activities, especially in SciMath Quiz Bowl. Okay, please put in mind that these are just stepping stones for you, right? Do not rush things over. You can actually learn that one step at a time. In talking about learning, it is a continuous process, meaning to say that your brain can actually absorb those one step at a time. You're not a computer, right? And of course, please bear in mind that your lessons are part of it. Okay? Do not forget your lessons. How can we retain the knowledge? Simple, by familiarizing it rather than memorizing. Right, let's continue. We already did discuss the great deal of energies used up, transferred again from one tropic level to another. It becomes lesser and lesser. Okay. Let's move now to the biogeochemical cycles. When you say bio, it's life, geo, it's earth, and chemical cycle involves, okay? These are life and earth cycles or chemical cycles. In addition to energy, living things also need nutrients to survive. Okay, these nutrients are found in the environment and are being used and reused by living things through pathways. Okay, biogeochemical cycles are any of the naturally occurring or circulating pathway of the essential substances needed by organisms to live. These essential substances come in various forms and they flow from the non-living or abiotic components. When you say non-living things, it's abiotic, to the living components or biotic components, and back to the abiotic components again. And the cycle repeats again and again. These substances that cycle in nature may be classified as into two, okay? Namely macronutrients and micronutrients. What are those? Let's discuss it later, okay? Macronutrients are essential substances that are needed by an organism in large quantities. If it is in large, it's macro, okay? Macronutrients include water, carbon, hydrogen, oxygen, nitrogen, phosphorus, sulfur, and calcium. How about micronutrients? Okay, micronutrients are essential elements that are needed by living things in a minute quantity, meaning to say in a lesser quantities. Micronutrients include zinc, iron, iodine. What else? Molybdenum. What else? Zinc and selenium. The vitamins. We need those micronutrients, okay, in order for us to do or to perform those metabolic processes. Okay, we can actually observe this one in our vitamins, our capsules, our syrups. You have these micronutrients in there. Decomposers help in recycling these nutrients in the ecosystem. Remember the decomposers, okay? When the top consumer dies, the action of decomposers returns the nutrients or the vitamins or the minerals to the soil or back to the ecosystem. Okay, they convert some of the nutrients into forms that producers can readily use. This is the reason behind that it is advisable to do the humus at home. Okay, humus are dead organic matter. You cover it with soil, and those or the action of decomposers can actually convert those back in nature in soil in order for the plants to absorb it again. Okay. Some biogeochemical cycles are based on parts of the environment that act as reservoir for specific elements. Okay. In hydrologic or water cycle, okay, this is the first. Oxygen and hydrogen are being used and reused as molecules of water. Okay. Take note that water cycle is the master cycle. Okay, the mother cycle, it is the master cycle of all the cycles. Let's take a look at later why water cycle is considered as the master cycle or the mother cycle. In carbon and nitrogen cycles, the gaseous form of carbon and nitrogen are the ones that are readily available in nature. Okay? More of these will be discussed in the following sections later. Okay? The cycle is the most, okay, this cycle is the most known and the simplest biogeochemical cycle. It's said that a person can survive for a longer period of time without food than without water. Okay, the water cycle. The main reason for this is that the human body is composed or comprised of up to 60% water, correct? And we lose water through the normal body processes, sweating, urination, what else? Defecating, okay? We lose a lot of water in that process. And again, we need around 60% because we are 60% water. Even your blood is composed of water. Deprivation of this nutrient consequently means that our body cannot function properly. Or if you are dehydrated, you cannot actually function properly. You might have a headache. What else? Or certain death, if in case you're dehydrated. This reflects to the importance of understanding the role that water plays in the lives of organisms. Okay? If an organism again deprives with water, that organism may die because of dehydration. Okay, it can cause death. Okay, this is the water cycle. As you can see, okay, as you can see, it started with evaporation process. Okay, evaporation. Okay, condensation, precipitation. Plants do transpiration. Okay, they release water vapor in their leaves, okay, in the process of transpiration to return back again the water in the atmosphere. Precipitation is raining, okay. Once there is precipitation, tendency is there is filtration. So the water will actually go beyond and of course in the subsurface. It will create a subsurface outflow and go back again to the surface. Okay, in order to perform again evaporation, and the cycle repeats again and again. Why do we consider this as the master cycle? Simply because it powers up all the cycles. Okay, even the nitrogen cycle. Okay, the nitrogen cycle will always based on the water cycle. Okay, the fixing, the nitrogen fixing bacteria. Even the lightning can actually fix nitrogen. We cannot use nitrogen unless it is actually fixed. Okay, let's move forward. Do you have any questions so far? Question?
None, sir.
None.
Okay. In water cycle, water stays as water and is not needed to synthesize new molecules. The ocean is the biggest reservoir of water. Reservoir of water containing at least 97 if the Earth's water. Okay, solar energy is the main driving force of water cycle. Okay, because evaporation will base on the heat, will base on the solar energy, right? Precipitation, on the other hand, is water coming back down after condensation to the ground in the form of rain, snow, sleet, or hail. Have you seen a hailstorm? Hailstorm, are you familiar?
Yes, sir. It's like
Right,
ice cube raining.
correct. It looks like ice cubes, raining ice cubes. Most of the water that evaporate come from different bodies of water like ocean, lakes, and streams. Okay? Even now, it is our situation now is raining. Here in our area, it is raining already. So raining is an act of precipitation. The water is coming back down to the ground. Okay? However, water can also evaporate from soil. But this does not mean that all water from the soil become vapor. Some water is also absorbed by plants' roots. Take note, before evaporating from the leaves through transpiration. Okay? Again, plants perform transpiration. Okay? What is transpiration then? Some water also absorbed by plants' roots before evaporating from the leaves through transpiration. Transpiration is converting water into water vapor. Okay? It is converting water into water vapor. Carbon cycle is based, let's move now to carbon cycle. Okay, the next cycle or biogeochemical cycle is the carbon cycle. Okay, carbon cycle is based on carbon dioxide, which makes up around 0.3% or 0.3% of the atmosphere. It can also be found in bodies of water as dissolved CO2 or dissolved carbon dioxide. In fact, there is more CO2 in the oceans compared to the atmosphere. Okay, if CO2 will be mixed with water, the water becomes carbonated, just like your sodas, your soft drinks. Okay. Again, in oceans compared to the atmosphere, producers on land and in water take in carbon dioxide from the environment to perform photosynthesis in the light-independent reaction. Okay. Again, carbon dioxide is used also in photosynthesis, but not in the light-dependent. It is in the light-independent reaction. Okay. And similar to energy, consumers require carbon from producers. Detritivores release CO2 back to the environment as a product of cellular respiration. Are you familiar with detritivores?
No, sir.
Okay, detritivores, these are organisms that eat dead organic matter or detritus. Okay? They actually fed on dead organic matters. Okay? So this is now the carbon cycle. As you can see, it started with the consumption of fuel. Okay, it will actually form CO2 building. That is why, sure, what is the implication if we have a lot of CO2 in the atmosphere? Tendency is there will be what? A greenhouse effect. Okay, greenhouse effect in the sense that it can cause global warming and changes, of course, of what? Of weather conditions or phenomena. That's the effect of global warming. Okay, so this is phenomenal. Combustion of fluids, it can create CO2. Animal respiration, including us, we actually exhale CO2. Okay, plants respiration, it can also cause CO2. Okay, here comes the point that CO2 can be used by plants for photosynthesis. So it will be absorbed by plant. Okay, and of course, after creating sugar or glucose from the carbon dioxide being used by plants in the light independent reaction of photosynthesis, it will be consumed again back by what? By animals. Okay, and decomposition, and the cycle repeats again and again. Take note that fossil fuels are these are non-renewable resources. So once it is actually consumed, you cannot replace that one. You can create fossil fuels for millions of years, right? So again, when an animal or a plant dies, it will return to the soil, and again, for millions of years or thousands of years, it will be converted. They will be converted into fossil fuels. But again, these fossil fuels are non-renewable resources. We cannot renew fossil fuels. Otherwise, we will have a lot of millions of years in order to create them. This is the carbon cycle. Again, the main function or the main character in the carbon cycle is the plant. Oh, right? Without photosynthesis, we cannot fix the CO2. We cannot use the CO2. Okay? Afterwards, once plants already absorb the CO2 and included in the process of light-independent reaction, they will now create glucose, which will be consumed by the animals, including us. But it does not stop there. Dissolved CO2 becomes calcium carbonate, okay? When mollusks extract and combine it with calcium to form their shells, okay? Just like your coral reefs, your mollusks, it is actually what? Composed of calcium carbonate, which is a mixture of CO2 and calcium. When they die, their shells are buried under the sea deposits and may become limestones. Through time, limestones are broken down, which gives us an aquatic organisms another source of CO2. So this is now the cycle. Fossil fuels are formed over a long period of time. Okay, evidence suggests that they come from the remains of ancient forms of life. Okay, over millions of years, high temperature and pressure transform the carbon in these ancient life forms into coal, oil, and natural gas. So that is your fossil fuels. Okay, these fossil fuels also stored energy from the sunlight and thus require or acquired by producers, then move on to the consumers. Okay, human activity involving the burning of these fossil fuels release CO2 into the atmosphere. Take note, if there are a lot of CO2 in the atmosphere, tendency is, again, we will have what? The greenhouse effect. Global warming, and tendency is changes in the climatic conditions. Oxygen cycle. This is really common because we are using oxygen also. We are aerobic organisms. The oxygen cycle, comprising about 1/5 of our entire atmosphere, oxygen is known to exist on Earth in substantial amount. Okay, meaning to say that it needs an organism to create oxygen, since it is with the limited supply. We have a limited supply of oxygen here. It is a product of billions of years of photosynthesis. And through respiration, it reacts with reduced organic material. Okay? To illustrate just how much oxygen there is, even if photosynthesis is not present and respiration consumes all the organic material containing oxygen, there will be still a substantial amount of oxygen left in the atmosphere, meaning it is not enough for all the organisms to use. Okay, so this is now the oxygen cycle. As you can see, carbon dioxide is being absorbed by plants in the process of photosynthesis, specifically in the light independent reactions. It will be absorbed by plants and what release the oxygen in the atmosphere. Okay, once the plants release the oxygen in the atmosphere, because oxygen is the byproduct of photosynthesis, it will actually used by animals and other aerobic organisms, meaning to say if it is aerobic, it is an organism that uses oxygen to live for metabolic processes. Are you still with me? Do you have any questions so far? Questions so far?
None.
No. None.
No, sir.
All right. Again, once the plant absorbs carbon dioxide, okay, it will absorb the carbon and it will release the oxygen in the atmosphere, because oxygen is the byproduct of photosynthesis. After which, oxygen will be used by animals and other aerobic organisms for metabolic processes. And we exhale carbon dioxide back in the atmosphere for the plants to use again for photosynthesis. That is now the cycle. Okay, the oxygen cycle. The oxygen cycle is simple. Through sunlight, carbon dioxide and water are converted into chemical energy in the process called photosynthesis. This is the food-making process of plant. At the same time, it has a byproduct, which is oxygen. Okay? This energy is subsequently stored in glucose band. So, what is glucose then? It is a simple sugar. Okay. If you're going to check on the chemical formula of glucose, it is C6 or carbon 6, H12 or hydrogen 12, O6 or oxygen 6. Okay. So it has oxygen on it. Through the respiration, oxygen is released and is taken in by heterotrophs or consumers, which in turn give off carbon dioxide, and the cycle repeats again and again. Okay, because they release carbon dioxide, those carbon dioxide will be absorbed again by the plants in the process of photosynthesis. And the cycle repeats again and again. Okay, let's move now to the nitrogen cycle. Okay, the first we have water cycle. The second we have carbon cycle. The third we have oxygen cycle. The fourth is the nitrogen cycle. Okay, what's with the nitrogen? Nitrogen comprises about 79% of the atmosphere. Our atmosphere is actually 79% nitrogen. It is vital to the vital part of proteins, many vitamins. Your DNA is in nitrogenous base. Okay, your DNA or deoxyribonucleic acid, and your RNA is ribonucleic acid. These are your genes. Okay. However, unlike oxygen and carbon dioxide, neither plants nor animals can readily use this gas. We cannot use this one. Okay. Plants need it in the form of nitrate or ammonia. How can we convert this into nitrate and ammonia? By nitrogen fixation. Okay. Nitrogen in the form of ammonia undergoes a process called nitrogen fixation. You need to fix the nitrogen in order to use. You cannot directly use them. Okay. Wherein it combines with hydrogen through the synthesis of certain bacteria or nitrogen fixing bacteria. This bacteria thrives in water, in soil, and in symbiotic relationship with plants. And take note, if there is lightning, okay, a lot of nitrogen is being fixed. Lightning or precipitation is part of the water cycle. That is why we consider the water cycle as the master cycle or the mother cycle. Okay. Detritivores can also produce ammonia via amino acid and urea, which are found in dead bodies and wastes. On the other hand, nitrate forms when some bacteria converts ammonia into nitrate in the process called nitrification. Okay, nitrification now plays a vital role. Why? Because plants need nitrates and nitrites, okay, in order to perform also their metabolic processes. These will now absorb by the plants, and again, we usually consume this after, okay? This is now the nitrogen cycle, okay? Starting from lightning, remember the water cycle, okay? Water cycle, okay? It actually fixes a lot of nitrogen, okay? Once fixed, even the bacteria also fix this nitrogen in the atmosphere, okay? It will actually consumed by plants. And afterwards, the plants, you usually consume the plants, animals. Okay? Again, once the animal is actually dead, or once an animal will die, the decomposers act on it to return again or to return back those nitrates or ammonia. Okay? And with the action also of nitrogen fixing bacteria, it will be converted back, or the nitrogen will be converted back into nitrates and nitrites and absorbed back again by the plants. And the cycle repeats again and again. As simple as that. Do you have any questions so far?
None.
Question? Okay, about Jewel,
No.
Jim Bryce, Nino, Kalina, are you still with me? Claire,
Yes, sure, but no question.
Rhea, Eleazar, Greg, hi. Keisha, hi. Okay.
Alright.
Because of this limited resources, because of the activities of humankind, these cycles um, tends to this cycle has been disturbed by humans or human activities. Okay, how human activities affect the ecosystem. This is now plays a big part of the ecological importance of human. At the same time, what are the disturbances that human actually did in nature? These are the natural occurring biogeochemical cycles. But then again, because of human activities, there are a lot of changes and it affects the ecosystem much. Let's take a look at how human activities affect the ecosystem. Okay? How human activities affect the ecosystem? The most pressing and common environmental issue today is climate change or the changes in climatic condition. Why? What's in the climate change? Okay? Climate change is any substantial change in Earth's climate that lasts for an extended period of time. Okay, even now we are actually experiencing climate change. Sure. Okay, right? We are experiencing climate change. Why? Why we're experiencing this? Supposed to be this is naturally occurring. Okay, let's take a look at. It is a long-term shift in weather patterns in specific region or globally. Okay, one aspect of climate change is the global warming, okay, which refers to the increase in Earth's temperature in the atmosphere and in the oceans. Once there is an increase of temperature, tendency is there are certain species of animals and plants that may die. Sure. Why? Because they cannot adapt. Adaptation also plays a vital role here. Okay? The survival of the fittest. The elimination of the weak. Okay? Because of global warming, because of this climate change, a lot of species of plants and animals die. Okay? And what are the causes? Let's take a look at later. Global warming has many different causes, but most of it are commonly associated with human interferences or interference, meaning our human activities. Specifically, the release of excessive amount of greenhouse gas, which is your CO2. What else? What are some greenhouse gases? We have the CFC. Are you familiar with the CFC?
No.
No.
CFC is a
No,
chemical,
sir.
chlorofluorocarbon. Chlorofluorocarbons are actually used in your aerosols, your sprays ba? Okay, your Baygon, your what else? Your spray nets, your what else? Your disinfectants with aerosols with pressurized air containing CFC. So it actually contains chlorofluorocarbons. Same as with your CO2, it can cause greenhouse effect or global warming. Okay, where's Clint, by the way? Yeah, all right, let's continue. Do you have any questions so far?
None.
Question? But you
None,
are
sir.
familiar with climate change already in your previous years, okay? And with these greenhouse gases. All right. Collectively, atmospheric molecules of carbon dioxide, water, nitrous oxide, methane, and chlorofluorocarbons are called greenhouse gases. These are the greenhouse gases, okay? Because they act like panes of glass in a greenhouse, okay? Have you seen a greenhouse?
No.
Okay. A greenhouse is it looks like an area wherein plants are actually covered with something in order to trap heat. That's a greenhouse. Okay, greenhouse effect is just like covering our own atmosphere with a shield. Okay, with a shield of these elements, these compounds, which traps heat. And because there is a trapping of heat inside Earth, tendency is there is global warming. Okay, wavelengths of visible light pass through the greenhouse gas as they travel from space to Earth. But the Earth absorbs this wavelength of visible light and emit heat. However, this is the case. However, heat does not escape from Earth to the space right away because it is being impeded by the greenhouse gas. We are now trapping the heat. This is the reason why Venus is the hottest planet compared to Mercury. Why? Venus has a greenhouse gas on it. It has CO2 in there. Okay? And because of this CO2, it traps heat in Venus. So it is the hottest planet compared to Mercury. Mercury is the closest planet among all the planets in the solar system. It is the closest to the sun, but Venus is the second planet from the sun, but it is considered as the hottest because of these greenhouse gases. This is the reason behind. Okay? They absorb heat and radiate it back towards the Earth. Because of this, heat builds up in the lower atmosphere, making the temperature near Earth's surface higher. This warming action is called the greenhouse effect. Okay, what is the harm or the harmful effect of this greenhouse effect? I'll give you this one. If there is a greenhouse effect, okay, there will be a global warming. Once there is global warming, okay, the polar regions, okay, polar area will dissolve, the ice there will melt, returning back to ocean, changing now the salinity of water. If there are some changes of the salinity of water, salinity meaning giparaton, okay, salinity. If there are some changes in the salinity of water, tendency is there are a lot of species of plants, species of fish that might die because of these changes in the salinity of water. Okay, if there are a lot of fishes that may die, our major source of food will be affected, humans. What else? We also are affected of this greenhouse effect. If there are some global warming, okay, tendency is there is excessive evaporation. If there is some excessive evaporation, it is really hot. Tendency is there is also excessive rainfall or precipitation. If there is some excessive precipitation, what will happen to our environment, to our area? We will have flash floods, landslides, and so on. Okay, so we are affected by this phenomena. It is a global phenomena. Okay, let's move forward. If not for the greenhouse effect, Earth's surface would be cold and incapable of supporting life. However, the increase in greenhouse gases is also not beneficial to living things because, again, it creates a lot of heat. Although we are actually, we really need this greenhouse effect, this heat from the sun, but we need to radiate it back to space. But then again, we cannot do it because of these greenhouse gases. Do you have any questions so far?
None.
None.
Did you understand the lesson,
Yes.
everybody?
Yeah.
Sir.
Okay, let's move forward because your periodical test is fast approaching. That's next week. Next week, I think. 15 and 16? Am I right? Okay. 14, 15, and 16. So next week. Right? We need to prepare a lot of things pa. Right? One harmful byproduct of human activities is pollution. Okay. Pollution. Pollution is the discharge of toxic or any contaminating substances that have adverse effect on the living things in the environment to which it is released. Like for example, you are releasing, you are draining soap, your dishwashing liquids, for example, in the rivers. It can actually have a harmful effect. What else? Chemicals. Okay, you're releasing a lot of chemicals. Factories are releasing a lot of chemicals. This can cause pollution. What else? Your cars is actually producing a lot of carbon monoxide. It can cause also pollution. So there are a lot of things that can cause pollution here. Okay, although pollution can also be a result of a natural disaster, majority of the pollutants contaminating the land, water, and air are due to human activities, are due to us. If we gain profit on it, then we will do it. That's the concept of human actions, right? Give me a human action that can cause pollution. You go.
Kuan. Driving car and throwing garbage everywhere.
Throwing garbage everywhere, yes.
Pollutions.
What else? Again, Claire?
Pollution.
Give me a human action. What are human actions that can cause pollution?
Burning plastic, sure.
Burning plastics. Yes, because you're